All right, exercise 14K. This is now adding on extra symmetry properties on top of what you've already learnt. If you understood 14E and 14F really well, then you might have already done this. So some of the questions in our quizzes, I've already put in things that were similar to this. So if you were able to do them, then this is pretty straightforward. If you didn't understand it then this may seem very confusing. All right, so we'll start off with the first example over here. Example 24, they tell you that sine of an angle is equal to 0.3. So hopefully at this point, you can visualize what they're trying to say here, okay? When I see that, I'm not thinking, oh my God, trig. I'm just thinking unit circle, and I'm thinking, what are they telling me right now? All I know, in a unit circle, sine of an angle, so an angle is, say, I don't know what theta is at the moment, so I'll just call that theta. All I know is that when I've got that angle, sine, which is the y value, that means this point here, the y value is 0.3. That's all I know. That's what they're trying to tell you. They're just trying to tell you that this height right there, which is the opposite side, is 0.3. That's all they've told you. Okay, so nothing else. So if you had to really zoom in or take out what you've learned from that first piece of information, they're just telling you you've got a right angle triangle, angle theta, this opposite length is 0.3. That's what they're trying to tell you. Okay, in one line, that's what they're saying. Now, they give you another one and they say, well, what about if I told you cos of a different angle called alpha is equal to 0.8? All they're trying to say here again is the same thing. In my mind, I'm just picturing a unit circle. There's an angle alpha that I don't know what it looks like, so let's just draw it up like this instead. That's my alpha. All I'm saying is at this point right there, I'll do it in green. At this point, I now know the x value because cos represents the x value, which is how long it is down here. Okay. They're just telling me that the x value is 0.8, and I don't know what the y value is. So if you had to interpret this, all they're trying to tell you is that when the angle is alpha, you will have 0.8 for this triangle. That's it. So that's what I want you to understand. When you're reading these questions, that's how you should interpret it. That's what it's trying to say to you. Yep.
What if it's the same as theta?
Yeah, yeah, they could. So if they said, if this was theta, so if they said cos of theta is equal to 0.8, then that means in this diagram, I now know that's 0.8. Because
you can solve it.
Yeah, exactly.
Are we allowed to calculate it? Or just...
Oh, good point. Yeah, there'll be a section for your application section. You have to use your CAS. Yeah. Okay, so that's how I read it. When they tell me the first 2 points, that's what I'm picturing. I'm picturing two right angle triangles. I've got a height and I've got an adjacent side. Now when you're answering the questions, see, A will make a lot more sense now. So A, they want you to find sine of pi on 2 minus alpha. So they're telling you which angle and which triangle you're working with. So this is alpha. If I drew out the diagram, so in my unit circle, pi and 2 is over here. This is where pi and 2 is at the vertical line 90 degrees. And you're minusing alpha. So that means you're moving back into quadrant 1 by alpha distance. So essentially, if you had to zoom in and look at this triangle over here, you notice that at this point, I've got this nice right angle triangle with the y-axis. This is different to exercise 14E because you normally draw your triangle from the x-axis. Now you're drawing it from the y-axis. But essentially, this is all they told you. This is your triangle. This is your alpha angle. If you compare that to the alpha angle that you have over here, well, we already know the adjacent side should be 0.8. So I already know this is 0.8 based on that diagram. So can you see what I'm doing? This is what they gave us. This is the question. All they said was sine, which is to find the y value. At this point, what is the y value? Y value is the height, which happens to be the adjacent side. That's my adjacent side. I happen to have 0.8. So the answer, sine of this, which is find the length of this, the y value is clearly positive, and it's positive 0.8. So this is how I like to teach it. I don't want you to be memorizing this. This is what they'll get you to do normally. They'll get you to memorize that. So So pi on 2 minus theta is equivalent to cos theta. You don't need to memorize these properties if you understood the unit circle. Otherwise, there's just too many properties to learn. So it's much better if you understood what the triangles are doing. That's what you're working with. You don't need to memorize these 4 extra formulas in a way. Yes?
So isn't it like useful to memorize it? It's like, I don't know, when you're trying to graph like a sine graph or something, there's some weird like translation, you can just simplify it really easily without having to think about it too much.
You could, but again, if you've understood it from a unit circle perspective, then you can still figure out where it is. So it doesn't have to be pi on 2. See, the rules is so static in the sense that it's always pi on 2 minus theta. But you could have had a situation where it was 7 pi on 2 minus theta. And you should still be able to picture that it's still the same quadrant or in a different quadrant. So that's the goal. I'd rather that you are understanding where you are in the unit circle as opposed to following a set of rules and say, okay, this is equivalent to cos. See, for me, all I understand is this was cos of alpha, but that cos of alpha is equivalent to the sine of this alpha. And this alpha here was based on pi on 2 because that's where I started, but it doesn't have to be pi on 2. That could have been, that's 1, 2, 3 pi on 2. That could have been 5 pi on 2. Sorry, 5 pi on 2, 7 pi on 2. Okay, so I know as long as I'm starting here, I'm minusing, this height here is always going to be the same as cos of that angle. So that's what I want you to get out of it. I want you to picture it as a diagram from a unit circle rather than trying to memorize this, because this is static. It's not always pi on 2. It can be 3 pi on 2. It could be anything, but I need you to know why this rule works. Okay, and that comes from just being able to draw that unit circle. Okay, so the first answer there, what is my answer? I wanted to know what this y value was. So that y value, we can already see that, oh, my pen died, but that's okay. We can already see the x and y values at this point. Let me just do it again. That was x, I didn't know, but the y value is clearly 0.8. Okay, so I now know the answer is 0.8 there. Okay, let's see what you can do. Let's zoom in onto this side over here. What about cos of pi on 2 plus theta? Can you visualize that? Okay, so think about where's pi on 2? If I'm adding theta, which quadrant am I in now? Which quadrant am I in now? If I've got pi on 2 and I'm adding an extra angle, which quadrant should I be in? Second, very good. So I'm picturing I've got a second quadrant triangle. What I want you to now to picture, okay, so I'm going to draw it here, because my pen's not working anymore. The question in B says, I've got a unit circle, angle is pi on 2 plus theta, this is pi on 2, I'm adding theta. So there's an angle that I'm moving. So I'm in quadrant 2. This is what the triangle looks like. So that angle there is theta. So if you get up to that point, you now know, okay, so that's where I'm at. Draw that triangle out. This is what you have. You've got this triangle where it's moved across angle theta. This is the opposite side, that's the adjacent side. Take that and compare with your own original, because that's what they told you. They said sine of theta is equal to 0.3. This is the only piece of information you got. So looking at the 2, what do they want you to do? They want you to find cos. Cos means the x value. So this is the x value. That's how long it is. That's the x-axis value. Right here, they want to know what x equals to. Ironically, that x value is the opposite length. The opposite length, which is from here to here. But in our triangle, we already got the opposite length. It's 0.3. So that means I know this has to be 0.3, but since it's in the negative region, it must be negative 0.3. See what I'm doing? So I'm not trying to memorize the formulas. I'm literally reading what they've given me. This is what we have, and I'm transferring it to what the question is. And I always start off by asking, where am I in the unit circle? So the same thing with the next one, negative theta, same thing. Where am I in the unit circle? If you can figure that out, well, think about unit circle, negative theta has to be done this way. That's negative theta. Here's my triangle. According to that, this is 0.3. But because it's going down, the y value must be negative 0.3. So I already got my answer. C is negative 0.3. Okay, so each and every one of these questions, it's training you to recognize that when you did in 14E, it was always from the x-axis up, x-axis up or down. Now you're working with the y-axis moving forward or back. That's all you're doing. But the theory of it is still the same. Work with the same triangles, and you should be able to figure out your adjacent and your opposites. That's the difference. Okay. So it's a shorter exercise. If you have a look at this exercise here, that's what they do. So in each and every one of them, they give you 3 different triangles. Angle X, angle alpha, angle theta. So you should have 3 different triangles with different properties for each one. Tan might be the tricky one, but other than that, everything else is still the same. Find where you are in the unit circle and then apply that triangle, see if you can solve cos, sine, or tan. Now tan, out of curiosity, how would you do tan?
Sine of a cos.
Sine of a cos, good. Okay, so if you know what the sine value is, cos value is, sine is the y, x is the, obviously, cos. To find tan, we know it's the gradient. So for each and every one of them, you can use the Pythagoras' theorem to figure it out. So if you've got x, you've got y, you can use Pythagoras' theorem. Which is why, as you can see over here, I'm just going to move across. Because it's a right angle triangle, oh, I didn't copy it down. How about that? Right angle triangle, one of the nice things is you can actually use Pythagoras' theorem. This is your cos of the angle. This is your sine of the angle. That's the length. So, Pythagoras' theorem, a squared plus b squared is equal to c squared. We already know hypotenuse unit of 1. So put it all together. 1 is equal to cos squared of theta plus sine squared of theta. So those who do specialists, you probably would have seen that formula identity. And later on, methods year 12, they often use that to simplify your answers. So you might get some really large fraction, that's circular functions. But cos squared of an angle plus sine squared of an angle should equal to 1 based on the unit circle theory. Okay.